guys, so today what we're going to be continuing is, we're going to be continuing with proportions, but it's going to be us being able to set up our own proportions as opposed to being given them to solve them, right? And we're going to learn two theorems. One's going to be called the side-splitter theorem, the other one's going to be called the midsegment theorem. They sound more complicated than they actually are, right? So the first one we're going to focus on is what's called the side-splitter theorem. And exactly what it says is what it does. Side-splitter theorem is literally a theorem about having the sides of a figure split, right? Again, it sounds more complicated than what it's actually going to be. And what this says is, for example, let's take a triangle, right? If we had a triangle, what the side-splitter theorem says is if you split, and it doesn't have to be perfectly in the middle, it could be there. If I wanted to actually move it more down, you could. All a side-splitter has to do is literally split the sides, right? It could be there, it could be down here, it doesn't matter. It does not have to be in the middle of the figure. Side-splitter theorem says that if we split the sides, right? So if you split on this side and split on this side, think of it as this, where you're cutting it, here you're cutting it. As long as this and this side are parallel, so whenever you see those arrows, it means they're parallel, they're never gonna touch, then the sides are proportional, right? As long as you have the sides of a figure being cut and the bases are parallel, they're never gonna touch, then these sides are proportional, those sides are proportional. And when the sides are proportional, we can set up a proportion to figure out missing sides. Again, it's going to make a lot more sense when we actually start setting them up and solving it, but the side-splitter theorem just goes into that. As long as you split sides and the lines are parallel, then you can set up proportions because the sides are proportional, right? So let's say we had this. And best way to show you is by actually working through one, right? Let's say that this side is going to be 10, this side is going to be 8, this side here is going to be, let's call this one M, and then that's 6, right? So this is 10, that's 8, this is 6, that's M, right? What I want to do is, let's say I wanted to solve for M. I would have to set up a proportion to solve them. And again, when we were working with proportions the other day was two fractions equal to each other. And so you know how to solve proportions. Question is, can you set them up? And now when we're given this, the way that you actually set up a proportion is by going in order, right? There's different ways that you can actually figure out the proportions, but you always have to go in order. So remember, it's two fractions. So one way you can do it is, let's say I wanted to write the first fraction as going from top to bottom. So if you wanted to go top to bottom, you can write 10 over 8, right? 10 over 8 goes top to bottom. And when you're setting up a proportion, you have to go the same way, right? You have to follow the same process. So if I went top to bottom here, the next fraction has to go top to bottom, right? It always has to follow the same order, because if you don't follow the same order, it will be wrong. So remember, if I went top to bottom, it would have to be top to bottom. And there's not just one proportion. I am going to show you a bunch of ways. Let's say I wanted to go bottom to top. If I wanted to do 8 over 10, so if I went bottom to top, then I would have to go bottom to top, 6 over M. Because it's the same relationship that's going on. Bottom to top, right? Let's say I want to do another one. And again, there's a bunch, guys. If I want to do another one, let's say I went 10 over M, right? So if I went 10 over M, I went left to right. So if I went left to right here, then I need to go left to right. 8 over 6. And again, in the end, it will all give you the same answer, because as long as you're setting up the proportions correctly, the answer will always be the same, right? What you can't do is ever mix up the information. So what I mean by mix up is, let's say I were to do this, right? If I were to do left to right, now if I do right to left, this would be wrong. This would not be right. And this wouldn't be right because, again, I went left to right, and then I went right to left. You can't ever mix up the order. Always go in the same order. So okay, I'm just going to pick one now because, again, the solving is the easy part. It's just setting it up. So first one we had, 10 over 8 equals M over 6. Because I went top to bottom. That's why my proportion is right. Because now once it comes to solving it, cross multiply. We have 8 times m, we have 10 times 6, right? 8 times m gives us 8m. 10 times 6 gives us 60. There's an equal sign in between. And then in order to get m by itself, we have to do the opposite. Opposite of multiplication is division. Divide this side too, right? 8's cancel out. And we're left with m equals, what? Sorry, 7.5. I'm sorry, guys. Equals 7.5. And that would be our answer. So if we're actually looking to solve it, we would know. M is 7.5. And that's how long this segment would be. Because again, whenever we have the side splitter theorem, whenever we have figures where the bases are parallel, then proportions will always be right and the relationship will always exist. Hardest part of this is always being able to set up the proportion, not solving it. But let me give you another one to see if you guys can actually get the hang of it. Because again, all it is, it's just a process, guys. You know what I mean? It's just getting the hang of being able to write it. Let's say I were to give you this one. And again, the problem isn't solving it. It's just being able to set it up, right? So I'm not going to solve this one. I just want to set it up for you guys to see. Let's say that this one was turned around, right? Sideways. Again, that just means it's parallel. And now I'm going to put variables here, right? I'm going to call this one A, right? Let's call this one C. Let's call this one E. Let's call this F. And let's call this H, right? And let's say that I wanted to put numbers, right? Let's say that would be 10. That would be 7. This one here would be 9, right? And what I want to find, I would want to find the length of AC. That's what I want to find. I want to find the length of AC. So which one is AC? We're looking for AC right there. And so what people can do, and I will leave this up to you guys however you feel comfortable. Since we're trying to find AC, typically people feel more comfortable having a variable there. If you want to use AC, you could. If you want to put a variable there, you could. It's up to you. I would say in this case, just feel comfortable putting a variable there if it makes you feel better. Anything that you want, right? So in this case, if I want to, I can just write the variable x, right? But you don't have to, right? Because in the end, we're trying to find the value of AC. So now if I wanted to set up this proportion, right? Again, first fraction, it's always whatever you want. So if I want to go 10 over 7, I could, right? And then think, if I went 10 over 7, I went top to bottom. So if I went top to bottom, this one has to go top to bottom. X over 9, right? The only thing you can't ever do, don't ever crisscross. Don't ever go from top left to bottom right. Don't ever do that, because then your proportions will be wrong. Always follow the same pattern. Top to bottom, bottom to top, left to right, right to left. Anything that's easy. Don't ever crisscross. So then again, we had top to bottom. So then we went top to bottom. If we wanted to, we could have gone 10 over x, right? Left to right. And if I went left to right, then I would go left to right. All right proportions, guys. If I wanted to do x over 10, if I now went right to left, then I would have to go right to left, 9 over 7. All correct, guys. These are all right proportion. Because in the end, what you're going to end up doing is multiplying 10 by 9, multiplying 10 by 9, multiplying 10 by 9. This is what I meant, guys. It doesn't matter how you do it, because in the end, as long as your proportion's right, your answer's going to come out right? And again, just to show you guys how it would look, just so you see it and you're not too complicated, I told you before you could have used x. You don't have to, because if I want to set up a proportion, I could have done 10 over 7, right? 10 over 7, top to bottom. And then since I'm trying to find AC, I can just write AC over 9, right? And in the end, though, even though it's not one variable, it's still the same idea, right? Where I would do 7 times AC, right? 7 AC. I would do 10 times 9, which is 90. Now, if I wanted to solve for AC, I would do the opposite multiplication, which is divide by 7. Divide by 7, the 7's cancel out. And then in the end, AC would come out to 12.86. Again, it's up to you guys how you actually want to do this and how you want to set it up. All right? Feel comfortable. The solving is the easy part. Then there's one more thing I want to show you. Even before I go to that, I want to show you too sometimes that if you forget about the picture, guys, the proportions are there for you. Proportions are actually written there for you all the time for you to see it if you can just ignore the picture. Because now if I were to get rid of the picture and focus on just that, we have it. Here's our proportion. 10 over 7 equals whatever that was, x AC over 9. We have it there. It's an easier way for always being able to see it, guys, if that helps. And then again, sometimes you're dealing with triangles, other times you're dealing with different looking figures. And again, the idea of side splitter, it doesn't matter what figure you're working with as long as you know that sides are parallel and they're being cut proportionally, right? Because if I have something like this, let's say, right? It doesn't look like a triangle, it's not a triangle, but as long as these sides are parallel, then automatically we can set up a relationship, right? Let's say that this would be, that's 12, right? I'll write it in a different color just so it's easier for you guys to see, right? Let's say that this is 12. Let's say that that's x. Let's say that this one here is 8, and that's 9, right? Again, it's the same idea, even though it's not a triangle, setting up a proportion, right? So first fraction I can write would be 12 over x, 12 over x. And if I went 12 over x, top to bottom, then I would have to go top to bottom. 12 over x, 9 over 8, top to bottom, right? And if I wanted to do 12 over 9, left to right, then it would have to be x over 8, left to right as well. Okay, that's practice, guys, with the side splitter, and that's how you set up proportions. I don't need to solve them because, again, you guys know how to solve proportion. The last theorem I need to get to, and it's also easier to explain, I believe, is called the midsegment theorem. And the midsegment theorem, it's exactly what it sounds like. It's a midsegment, right? And when people hear midsegment, they think correctly. They think middle. So midsegment theorem, right? And the midsegment theorem, we're going to apply it to a triangle, right? And so when you're dealing with the midsegment theorem on a triangle, it's exactly what it is. It's going to be a segment that's going to be perfectly in the middle, right? And here's the thing. For us to know that that's in the middle, we have all these points, right, which I'm just putting, just to be able to see it. If I have a midsegment, right, this would be our midsegment, let's say. For that to be our midsegment, what we would know, if this midsegment is in the middle, right, let's call it our midsegment. If that midsegment is in the middle, it means that this point's in the middle, right? If this segment's in the middle, it means that that point's in the middle of this. It means that that point's in the middle of that. Because if this is in the middle, then its points are also in the middle, midpoints, right? So if that's in the middle and this point's in the middle, this point's in the middle of that. So if that's in the middle, we know that this is going to be congruent to that, right? That's going to be congruent to that. Because again, if that's a midsegment, that's in the middle. And if that's in the middle, those two are the same. It's like me standing in the middle of a room. If I got 5 feet to one side, I got 5 feet on the other side, right? So again, that's a midsegment, so this point's in the middle. If this is a midsegment, this point's also in the middle. But this point now is in the middle of that segment, right? And since these two sides are different, I don't know anything about this side compared to this one. All I know is that this point's in the middle of that side. So if this is in the middle of that side, I know that this has to be congruent to that. But now I would put 2 tick marks because, again, I don't know if this is the same as that. I don't know if that's the same as that. What I did know is this was in the middle here, so those two are the same. And this was in the middle here, so those two are the same, right? Which now would be easy, because if this is 6, that would be 6. If this is 10, that would be 10, right? Again, the same side, as long as you have a midsegment, the same side, they're both going to be the same. Same side, they're both going to be the same. Now, the other relationship that exists with a midsegment is if this segment is in the middle, right? For midsegment theorem. If we have a midsegment, it means that this has to be parallel to that, right? They're never going to touch. And if these two are parallel and it's a midsegment, if this is, let's say, 5, right? I'm going to pick a different number just because I don't want to confuse you with a number that's already there. Let's say that's 7, right? If I'm saying that this midsegment is 7, we know that there's always going to be a relationship that exists. If the midsegment is 7, the base is going to be 14. And the reason that it's 14 is because the midsegment is always half of the base. Always. The midsegment is always going to be half of the base. So if the midsegment is 7, base is going to be 14 because it's half, right? Again, this is always going to be half the size of the base. Let's say the other way around. Let's say that the base now was 30. If the base was 30, I know that my midsegment would be 15 because same relationship. Midsegment is always half of the base. Base is always going to be double the midsegment, always. Base is always 2 times bigger than the midsegment. Midsegment is always half of the base. And remember, since this is a midsegment, this segment's in the middle, these 2 sides segments will be the same. These 2 segments will be the same. The left is not congruent to the right. Always keep that in mind. The left side has nothing to do with the right side. All we know is that the segments on the same side are always equal, right? So now let's apply this, right? I'm going to do 2 examples to show you how easy this actually is to apply, because it's not difficult at all, guys. It's just always remembering the property of a midsegment. So let's say again, let's say I had this figure, right? We have a triangle, and I'm going to tell you, here, let's make this G, let's make this L, let's make this R, let's make this S, let's make that T, right? I'm going to tell you that TS is a midsegment. TS is a midsegment of triangle GLR, right? TS is a midsegment, and they always need to tell you that it's a midsegment, right? Again, make that parallel to that. But the second that it's a midsegment, we know that that's true, right? It's in the middle, lines are parallel, all of that, right? I'm going to tell you now that this side here is 8. I'm going to tell you that this side here is 6. And I'm going to tell you that the midsegment is 9, right? What I want to find X, I want to find Y, I want to find Z. Now if I had this, again, always remember guys, since that's into midsegment, this point's in the middle, right? If that point is in the middle, I know that this is going to be equal to that, right? So automatically we know that Z is going to be 8 for the exact same reason, guys. That's in the middle. If this is 8, that has to be 8. Remember, it's always the same side, right? Opposite idea. If this is 6, right? This point's still in the middle on this side. If this side is 6, then automatically that has to be 6. Y has to be 6, right? And same idea. If this point's in the middle, if that's a midpoint, this is congruent to that, right? So Y is 6 because that side was 6. Z is 8 because those two are equal. Now to figure out X. If the midsegment is 9, remember, the base is always going to be bigger. It's always 2 times bigger. So if this is 9, X has to be 18. And it has to be 18 because, again, the base is always double the midsegment. So if the midsegment is 9, 9 times 2, 18. Right? I'm going to do one more. Right? And let's say, same thing, working with the midsegment. Right? I'm going to draw a triangle. Now I'm putting the triangle sideways, right? So we have that. That's a point right there. That's a point. Let's give that right there, right? I'm going to tell you that this is 11. I'm going to tell you that this is 9. Sorry about that. That's 9. Here, make it look better. that's 9. And now, instead, I'm going to give you the base, right? I'm going to tell you that the base here is going to be 24, right? Okay, I need to tell you, given a midsegment, right? Given the midsegment, so we know that that midsegment is there, right? So given this midsegment, we want to find everything now, right? We want to find this side, we want to find this side, and then we want to find that. We want to find A, B, C, right? So if we want to find A, B, and C, again, think. That's a midsegment, right? We're given a midsegment. So if that's a midsegment, same idea, this is in the middle. So if that's 11, this has to be 11, right? A equals 11, because again, it's on the same side. If that's a midsegment, this point's in the middle. So if that's 9, B has to be 9. And now be careful, because we want to find C. C is the midsegment. We know that we're given the base, right? If the base is 24, the base is bigger. So some people would actually do 24 times 2, but be careful, because if the base is 24, we know that the midsegment is going to be smaller, 2 times smaller, right? So if that's 24, we know C has to be 12, because 24 divided by 2 equals 12, right? You have to be careful with that, guys. Always remember, the midsegment is always half of the base, always, right? So if this is 24, that's 12, because 12 is half of 24. And you can check it, because 12 times 2 is 24. Again, that's the idea of a midsegment, guys. Just always be careful. It's not always a cross. Don't make B11, right? It looks like it sometimes, but it's not. Always remember, guys, midsegment, that's a midpoint. The same sides are always the same. Same sides are always the same, guys. 11, 11, 9, 9. Any questions you guys have, feel free to ask, guys, okay? Take care.